So let's start today class. While we're waiting the other two people to join us, we will review our tasks for the previous classes. So there were already three reports that you should be done. You done only one, and for the second one there are another example of report if you have some difficulties to do such reports. So let's review this example. So it can be done in any, has been said before, in any text document. For example, Microsoft Word is perfect. So what should be in your report? The same as in the previous one, as has been seen in the example. So first of all should be your name, then subject, and finally the title of work. For example, for recrystallization, the next should be the equations or the products of given work. For example, for the second work, there should be benzoic acid, the main substance. You should add its molecular formula and also structural formula. So the structure formula, you could build it in the ChemSketch. Later we also will work today in it to make some formulae. So also you should add molecular and structural formulae for side products or other products such as phenol, naphthalene, hydroquinone, and phthalic anhydride. So also should be molecular and structural formula as in the previous work. The next, there will be the table of solubility, the main table with the working numbers, working figures, which will we use in our task. And the next, there will be the description of work progress. There I just put the sentence that you should describe the order of actions according to the video. So you should describe what you see in the video under this title. So the next, you could see the structure of the installation or structure of the labware that is used for this class. So for the recrystallization process, you can see the two Erlenmeyer flasks, one for heating substance, the other for heating the filtered substance. So there should be two Erlenmeyer flasks, hot plate, and also glass funnel and paper folded filter. And so you could also add the apparatus for vacuum filtration to this structure. So that there should be very little, in fact, labware of this for the second task. So after that, you should answer the question about the video, some questions for the video, some questions for the for uh, for the presentations. You can find them also in the presentation if you can find them in the video itself. So we already answered those questions on the previous class, so I would not stop on it to examine those questions. So the next, after answering the question, there should be your task for the lab. as for use the table of solubility in water and decide if it is possible to use your substance for the recrystallization in water, and answer why if not. So we already reviewed those substances and reasons why they could be used and why they could not be used. And also there you can see the example for such task uh, in the presence of phenol. And finally, you should write the conclusions. There also some example is written. So you should write the conclusions about this method, what this method is used for, what kind of substances can be purified by this method, and what are its main advantages and disadvantages. The latter is not necessary for the next reports. It is exclusive for the purification tasks. So this method is used, for example, for purifying substances by recrystallizing them, and also its main advantages and disadvantages. One is already listed. The second, for example, you should decide for yourself. So we watched, for those who connected to us later, we watched the example of the second report. And you could see this example of report on the page mm, on the page for the where course is located. There you could see is example of report 2 is it's what example we just watched today. So the previous class was the physical properties determination, and we also should review the lab work which should be done in the form of report. So what should be done is in this report. So we should done the report on determination on physical properties. We should watch the video on determination. We didn't watch it the previous class because we were short on time. So let's watch it. It's quite short, and you probably already watched it because it was already on the course page. So let's start to watch it. So we watched the video. It would be quite useful for us when we watch how to do the report on this work. So the start of your report should be also your name, the subject. The subject for this work is the physical properties determination, and the title of work is melting point determination or determination of melting point. So the next there should be equations of the main product or for structure or formulae of products, and also there should be mm, uh, several products such as several isomers of nitrochlorobenzene, and we should build their formulae and structure formulae, and they already have its molecular formulae. See, six carbon atoms for hydrogen and one N atom, nitrogen atom, two oxygen, and one fluorine atom. So you should add to this to this page structural formulae for corresponding substances. So the next, you could see the table of physical properties of nitrochlorobenzene isomers. They are ortho nitrochlorobenzene, meta-chlorobenzene, and para-nitrochlorobenzene. So what you should add to this table? You should add systematic name by UPAC rules. There are some specific rules that substances should be named for. Also, you could find a molecular formulae, molecular molar mass of the substance, which is the same for all isomers because it has the same number of items. Also, you could see its melting points and boiling points, and also density. As you can see, for different isomers, the melting points are different, which would be a subject of today's work. So before we start, we should name those substances by systematic nomenclature, which is IUPAC rules. So it can be done on example for in ChemSketch program. For example, we should start from building the structural formulae for these substances. Let's start from the adding nitro group. So you could build a nitro group just by adding nitrogen atom and adding to it two oxygen atoms with double bonds. So there you could build nitrogen group by itself. Also, you could find it in the top right table. It's NO2. You could just add it to the all substances. So the next we should add a chlorine group. So it should be in second position, in third position, and in fourth position. So after that, you could select all the substances and even it by checking the clean structure. So they could be evened by itself. So the next we should name these substances. So as we could correlate to the presentation. As you can see, ortho-nitrochlorobenzene is position 1, 2, meta-nitrochlorobenzene position 1, 3, and para-nitrochlorobenzene position 1, 4. So we should add these names. So by clicking text box and name, the first would be ortho ortho-nitro chlorobenzene. It would be the first substance, and the other two we also should name it. We could just copy the name for the next substances and change its first root. So instead of ortho, the next should be called meta isomer, and the last in position 1, 4 should be called para isomer. So those are the names given by the special nomenclature, which is ortho, meta, and para nomenclature. If we have two substitutes, we could use such type of nomenclature, so or naming the substances. If we have more than two, or for example 1, 3, 4, 5, and 6 substitutes or group or different groups, we should use systematic nomenclature. So in this case, systematic nomenclature usually uses the most elder group, so from it should be start numerating the structure. So numerating structure, we should numerate the ring. For example, on one atom there should be we also could give numbers to atom. So we should, for example, start from the nitro group and add the numbers to the other atoms. For example, if we start numbering from the clockwise ring, there should be 1, 2, 3, 4, 5, 6. So the atoms that do not have any substitutes, only hydrogen atoms, they should not be numbered, but we should only number the atoms that have some substitutes, for example, nitro group or chlorine group. So it is the first type of numbering. The second type of numbering could be started from the carbon atoms that contains chlorine substitute. So it would be first the C atom, second carbon atoms that contains nitro group, and so on. So what numeration we should choose? So let's an example. You should already in your practical courses should already examine the nomenclature, especially for the organic substances that have cyclic structure, such as aromatic substances such as this, or simple cyclic structures, for example, like cyclohexane and so on. You should know that we should number the ring in so that total number of substitutes should be lower. So if there are several types of numbering is possible. For example, 1 nitro, 2 chlorobenzene. It's one option that we have, and the second option we have 2 nitro, 1 chlorobenzene, but it should be in the opposite order. So you should, as you know, you should add dash between numbers and letters, after letters and numbers, and after numbers and letters, and all letters should be connected without any spaces and without dashes. So there are two possible options. So what we should choose? We should, in this case, it's all these options have its names of its substitutes in the front of the main ring or main chain. In this case, chain is a cyclical benzene ring, so both of substitutes are located in front of this chain. So, as you know, those substitutes should be numbered in alphabetic order. So, first should be C in this case, after C should be N. So, the right numbering order should be started from C and connected by N. So because C comes before N in alphabet, so first should be chloro, then nitro. So the first, I mean 1 nitro 2 chlorobenzene is incorrect name for this structure. So correct name should be 1 chloro 2 nitrobenzene, because chloro comes before nitro. So the same goes for the next substances by systematic nomenclature. They should be also start with chloro, because it goes first in alphabetic order and then connected by nitro. So in the second case, nitro should be the third, number 3, because if we start from chloro, we could also add numbers to the atoms. It should be first, then we should go to the second substitute by the shortest path, which is counterclockwise in this case. And numbering the atoms 2 and 3. If we go clockwise, it would be 1, 2, 3, 4, 5. So we should choose the correct numbering order in which the number of carbon atoms that contain in substitute should be lower. In this case, it would be 1 and 3. So 1 chloro, 3 nitrobenzene. And finally, for the last substance, which is para-nitrochlorobenzene, there should be 1 chloro, 4 nitrobenzene. So, as in the previous cases, we start with the carbon atom containing chlorine and goes. In this case, we could go counterclockwise, clockwise. In this case, it is both the same, give the same result. So we have 1, 2, 3, 4. For example, if we go counterclockwise, it would be also 1, 2, 3, 4. So it always will be 1 chloro, 4 nitrobenzene. So when we have 2 or more substitutes, we should number them in shortest way. So you should, if there are several options, we should choose the option where the total number of atoms is lower. And finally, when we number the substitutes, they should be placed in alphabetic order. So first, for example, C, then goes N. There's some derivation from this rule, in which case, for example, we have instead of prefixes, suffixes. For example, benzoic acid. In some cases, there could be carboxylic group, which goes instead of prefix, in such as nitro and chloro, it's all names prefixes, and goes to the suffix. And for example, instead of benzene would be benzoic acid. So in this case, we should always start from such suffix. For example, if we have the same benzene ring, but for example, instead of nitro group, we have carboxylic group, and for example, the same chlorine. We should always start from the carboxylic group because it goes in the suffix. So such this I placed carbon atom, there should be fluorine. So for example, such substance should be numbered from the carboxylic, from carbon atoms containing carboxylic group, and goes the next to the other substitutes. So it should be called, for example, 2 chloro, and the next should be called the ring, which is in this case transforms to benzoic instead of benzene, benzoic acid. So in some cases it suffix. In this case it's suffix and additional naming, which is oic acid in this case. So in this case, oic acid is a suffix, and suffix always should come by number 1 in all numbering. Even we have, for example, some substitutes which goes before carboxylic group. So for such substances, that's all. So now we have all substances which are needed for our task. We should select all and paste them in our report. So in this slide we could add the substances. So we also could add, in this case I also can add some background to better to better see those. So orthonitro-chlorobenzene, which has systematic name 1-chloro-2-nitrobenzene. The next meta-nitro-chlorobenzene, which has systematic name 1-chloro-3-nitrobenzene, and the last para-nitro-chlorobenzene, which has systematic name 1-chloro-4-nitrobenzene. So we also should add these names in the table, which you will done will do by yourself, considering this structure formulae. And the next, after we've done all this, it would be the first task to give systematic name to the isomers. The next, we should write a description of work progress. For example, description could be done by watching the video which we watched earlier. So the initial substance, as you can see in the video, which is nitrochlorobenzene. In video also you could see its name, it's para nitrochlorobenzene. It was grinded in the thick wrought mortar to a fine powder. So you should you could see in the video there you given the substance which is contained in the thick walled clay ball, which is because it's thick walled, and it is called not evaporating dish but mortar. So in this case it is mortar, and because it is placed in the mortar, it was grinded before to a fine powder to be easily contained in the glass capillary. So then the substance was placed in the aforementioned glass capillary, which is sealed from one end, and the capillary with the substance is thrown through the glass tube several times until it packs densely enough to conduct the determination of melting point. It should be packed densely, because if it not packed densely, it will at heating it will melt, but but when you determine the melting point, you could confuse the packing of substances, because if the substances are not packed densely, they will deform it before melting, and the temperature of such deformation which will be much lower than actual temperature of melting. So to prevent such process, we should pack it densely, and the process of packing densely is thrown several times through the glass tube, usually 3 to 4 times. So after that, the prepared capillary should be attached to the thermometer ball, which is used to measure the temperature, and placed in the mm, melting point determination apparatus, which we will see on the next slide. So the temperature was initially evenly increased at rate 5 from 5 to 10 degrees per minute below 20 degrees of melting point. Then it it was shortened to 1 to 2 degrees centigrade per minute near the melting point to mm, to more closely or more definitely define the melting point. So the moment the melting starts should be marked and compared with a table parameter for this substance, and you should also write the conclusion about purity of the substance. That should be made in the last paragraph, which called conclusions. So such should be a description of the work progress. So the next, the parts of apparatus for determination of melting point, such as thermometer. The next major part is round-bottomed flask with a long neck. As you can see in the video, there's a testing tube in which is located uh, thermometer with the capillary capillary tube itself, the heating medium which is used for heating the apparatus evenly, and hot plate for heating such apparatus itself. So it is a simplified version of defining the melting point. You also could see the more complicated part, more complicated apparatus, which uses electronic heating, and also watch microscope to watch more closely at the substance to define to definitely mark the temperature when it melts. So there can be several types of such apparatus, but in this case we use the simplified type. The next, after the presentation of apparatus, we should answer the questions which are situated in the previous presentation. There are in total 7 questions, I think. Yes. So the first question: whether the following parameters are extensive or intensive physical parameters. Those questions are about the presentation. There you could find definitions of extensive and intensive physical parameters. In short, extensive parameters are those that have that depends on the amount of substance, and intensive physical parameters are independent of amount of substance. So depends of amount of substance are volume and amount of substance. Amount of substance is definition. Substance is measured in moles, and melting point, for example, in molar mass, are not dependent on the amount of said substance. So those are intensive parameters, and extensive parameters are volume and amount. So the next question: how was the sample prepared beforehand? Meaning before placing it in the capillary. And the three were three options. It was heated, it was grinded, and it was dried. So the right answer: the substance was grinded in the mortar according to the video. Because in the video we could see the thick-walled clay ball and a thick-walled clay ball called mortar. And mortar is used for grinding the large particles to fine powder. Large particles could be also crystals. So in many cases, the clear, pure substances can be found in the form of large crystals. They should be grinded to the much smaller form to be analyzed later. So the next, what was the type of glass capillary? This meaning what its parameters. And the answer: the glass capillary used from one end was used in the video. So glass capillary is a small glass tube with small diameter, and one end of this tube should be sealed to conduct such examination. So the next question: why was the capillary tube thrown through the glass tube? And the answer is: the glass capillary was thrown through the glass tube to pack the substance densely by gravitational force to make it easier to analyze its melting point. The next: at what part of a thermometer was capillary tube situated? And the answer: the capillary tube was situated at the center of a thermometer ball to measure the temperature evenly. The next question: what is the purpose of the liquid in a round-bottomed flask? And the answer is the liquid in the round-bottomed flask is used as heating medium to heat the substance slowly and evenly. And the last question, how do you determine the melting point of the substance? You could find the answer to this in the previous presentation on the subject. And the answer, when determining the melting point of the substance, you should measure 2 points. Usually it's 2 points for this work. It's 1 point when it starts melts. So nevertheless, first when the substance starts melting, the first droplets of liquid are appeared, and the second when the substance melts completely, leaving only liquid. So the shorter range between these 2 points, the purer the substance usually, because if it has some impurities, it starts melts at much lower temperatures and ends at higher temperatures. So this range is much wider. And finally, as a last task that you should done, you should determine what isomer of nitrochlorobenzene is examined and what its melting point. And as being seen in the video, according to the measured melting point, it's 84 degrees centigrade. We have para isomer of nitrochlorobenzene, which is para nitrochlorobenzene. You can see this in the table. So the melting point of nitrochlorobenzene is 84 degrees centigrade. And finally, you should do the conclusions of the work. So what is this method about? What is measured by this method? So this method of physical property determination is used for determining the melting point of substances. The substance undergoing the process should be pure, otherwise the measured melting point will be lower with the presence of the impurities. And in the current work, we determined the melting point of nitrochlorobenzene isomer, which melting point is 84 degrees centigrade. It is such melting point corresponds with the melting point of para isomer of given substance. So the name is para nitrochlorobenzene, and the melting points correlates with the table parameters. So it means the research substance was quite pure. So because its melting point is close to table parameters. If it were much lower, then it would mean that the substance would be contaminated with impurities. But in this case, it is pure because measured melting point is correlates with table parameters. So this is all on the previous report. What should be included in your report all is presented on this slide. So if you done any notes, so you could easily make this such report. So the next today's work would be we will be dealing with the separation method which is called thin layered chromatography, which is method of separating of organic substances. And you could find also this presentation and video on the main page of this course. It has number of 6. So first of all, chromatography. We will be dealing with chromatography, and first of all, what chromatography is. Chromatography is by itself it's a technique used to separate the components of the mixture. So it is a separation technique. It also can be called um, uh, refining or mm, purification technique, but in this case it's more used for separation for analysis. So it because of that it comes in another category, such is separation. So it can be used as an analytical technique to gain information about what is present in a mixture, or as a purification technique to separate and collect components of the mixture. For example, such as done in column chromatography. The first uses of chromatography involved separating the colored components of plants was used in early 1900s. The pigments in a plant can be separated, for example, into yellow, orange, and green colors. Xanthophyllus, Carotenis, and Chlorophyllus, respectively. So they have each has corresponding very different color through this method. The Greek name for color is chroma, and graphy is to write also in Greek. So chromatography can be translated as color writing. The chromatography in organic chemistry laboratory can be classified in several broad categories. You could find it could be liquid and gas chromatography by itself. So this method is based on the difference of movements rates of the component concentration zones in different media, which move in the flow of the mobile phase, which is called also eluent, along the layer of stationary phase, and the investigated compounds are distributed between those two phases. Usually the stationary phase is a sorbent with a developed surface, and the mobile phase is a flow of gas, as in the gas chromatography, or vapor or liquid, which is in the liquid chromatography. Uh, Depending on the state of aggregation of the mobile phase, they are distinguished as gas chromatography and liquid chromatography. Among the liquid chromatography, there is another classification according to the geometry of the absorption layer, the stationary phase. Uh, th- there could be column and flat layer chromatography distinguished. Finally, the flat layer chromatography includes thin layer chromatography, which is called TLC, which we'll be dealing with today, and paper chromatography, which is uh, more simple method of chromatography, which usually used more cheaper and more simple. But today we will be dealing with thin layer chromatography, which is can be mm, can be connected to liquid chromatography because it has uh, liquid mobile phase. So about the thin layer chromatography, this method is also a method of separation, such as all chromatography methods, analysis and physical and chemical research of non-volatile substances. So the main uh, mm, usually this method is used to separate non-volatile substances. This is its characteristic of such method. Thin layer chromatography, which is also shortened to TLC later, is widely used in laboratory practice as a method for identifying substances. The basis of thin layer chromatography is the difference in the movement rates of mixture components in flat thin layer of the sorbent, which is stationary phase. It's also called adsorbent. When the solvent mobile phase, which also called eluent, uh, moves over it. So the stationary phase usually is such substances as silica gel, aluminum oxide, cellulose, polyamide, and many others. So the mobile phase eluents or solvents is usually organic solvents of different polarity, and their mixture with each other of with different solutions of acid, alkalis, and salts. So in stationary phase, usually used silica gel or aluminum oxide, and for the solvent or mobile phase, I use different organic solvents. And the choice of such solvents should be the next. So the proper solvent selection is the most important aspect of the thin layer chromatography, and determining the best solvent may require a degree of trial and error. So this is the trial and error process to choose the right solvent or solvent combination. Uh, you should keep in mind chemical properties of analyzed substances. A common starting solvent is usually one-to-one polar and non-polar solvents such as hexane, for example, or and ethyl acetate. So usually 1-to-1 ratio of polar and non-polar. So non-polar solvents such as hexane, heptane, octane, for example, toluene, those all non-polar solvents. And varying the ratio can have a pronounced effect on so-called retardation factor. You could see on the top picture the different dots located on the uh, TLC thin layer chromatography plate. Those dots correlates with different substances, and the better separation, so the higher the retardation factor, so called. So if dots located too close to each other, this is bad. This means is the chosen solvent is not is bad solvent and not acceptable for such process. So the best result is in the middle, for example, where we have one-to-one ethyl acetate and hexane, where we can see the more complete separation of different substances, which are the dots on this plate. So those retardation factors values can range from 0 to 1, with 0 indicating that the solvent polarity is very low and 1 indicating that the solvent polarity is very high. So as you can see, hexane is very low, so its retardation factor will be close to 0, and for example ethyl acetate has uh, very high, so it's almost to 100% very high retardation factor. What is retardation factor we also will we'll see later. But it is usually mm, a ratio of dist mm, of of path that such dot traveled to the finish line. Finish line usually located at the top uh, of every plate. You could see it at the top. So the path that dot mark traveled to the from the start line. Start line located at the bottom. We also will review this later, what this means. And when performing your experiment, you do not want these values to be too high or too low. So it should be somewhere in the middle. The best results when the dots are separated, they have high distance between them, and they situated on much more surface. So this tells us about the best result. If the value is zero, you should increase the polarity of the solvent to higher. If it's close to the top, so it's close to retardation factor is close to 1, so you should decrease the polarity of the solvent. And by such examples, you should choose the right combination of the solvents. By this example, by making the trial chromatography. So if you know that one component of the mixture is insoluble in the given solvent, but another component is freely soluble in it, it often gives you good separations. And how fast compounds travel in the plate depends on two things. The first, if the compound is soluble in one solvent, it will travel further up on the chromatography plate, and how well the compound likes the stationary phase. Stationary phase is the material which is made the chromatography plate of. Uh, so it is usually very, or not very, but moderately polar compound. So how well the compound likes the stationary phase. If the compound likes the stationary phase, it will stick to it, which will cause it to not move very far from the chromatogram. And you should be able to determine which by looking at value of retardation factors. So, for example, in first case on the second bottom picture, it has low retardation factor because both substances close to the starting line. Starting line is the bottom line. The second has the better retardation factor, and the top one has the best retardation factor and is the best separation of two substances. So, for example, 30% of methylene chloride in hexanes is the best result for the solvent for such substances, separation of such substances. So the next about the thin layer chromatography, about the solvents. You can be deal with the acids, bases, and strongly polar compounds, which often produce streaks rather than spots in neutral solvents. As you can see on the right picture, there instead of dots, in comparison to the others substances, you could see a streak, which is because of that streak, almost a line. It is harder to determine where we should uh, mark the resulting substance. And to prevent formation of such streaks, we should add some substances to this to the solvents to prevent them. So adding a few percent, for example, of acetic or formic acid to the solvent can correct streaking when we're dealing with acids. For example, similarly for the bases, adding a few percent of 3-ethylamine can improve result, and for polar compounds, adding a few percent of methanol can also improve the results. You should also consider the volatility of the solvents when dealing with uh, the chemical stains. Uh, any solvent left on the plate may react with the stain and conceal the spots, and many solvent can be removed by allowing them to sit on the bench for a few minutes. Most of the solvents, but few of them can be very non-volatile, so they evaporate very slowly, and they can be require a vacuum chamber to fasten the evaporation process. So volatile solvent should always be used also once, and if a vial phase is used repeatedly, results will not be consistent or reproducible. So the next we will review how to conduct thin layer chromatography. So preparation, in this case we should consider how to prepare the sample of chromatography plate. So first of all, there should be drawn two lines. Usually, in some cases, you could drawn one line, such as called spotting or starting line, which is drawn at length at 1 to 1.5 centimeters from the bottom of the plate. If you have different plate, it could be lower if layer of the solvent is lower. So because such spotting line should not connect the layer of the solvent, and we will see why later. And the second line should be drawn at the opposite side of the plate from the top of the plate. So as you can see on the both pictures, starting line on the one side of the plate, the solvent front or the solvent front line should be at the so-called finishing line should be at the top of the plate. So all the samples should be located at the starting line, and finishing line also could be marked, usually drawn lightly by the pencil, because such plate has very lightly damaged material that can be damaged by drawing on it. So you should draw very carefully. The distance between two lines could be differentiated, but it will be better if it will be the same. For this work, we will see in the video that it will drawn at the same distance at 55 millimeters for this work. So from the start line to finishing line, the front of the solvent should be ended. So as been said before, drops of the sample of solution applied to the spotting line with the capillary. Usually with the capillary, also that could be done with the pipette. If you have pipette with a very small diameter, and the sorbent should be evenly distributed on such plates, so there shouldn't be areas where it scratched or damaged. So such plates with scratched or damaged sorbents on it should not be used for such process. Several samples also could be applied to the starting line. For example, in the top picture we could see only one sample at the starting line. On the bottom picture we could see 4 samples. And in this work we also use several samples, to be exact 4 different samples. The substance content in the sample should be in the range from 0.05 to 50 milligrams. So it can be measured by pipette or by the glass capillary. After applying the sample to the stationary phase, the solvent is allowed to evaporate. So after, usually we apply the substance which is dissolved in the solvent. So after applying, we should wait some time to such a solvent to evaporate. So the next, when we will have already the chromatography plate, which has marked starting and finishing line with applied samples of substances, could be clean substances or mixtures of substances which is separated after it is solvent from those samples are evaporated. We could place such plates in the chromatography mm, in chromatography container. So first of all, the solvent or eluent, or is called also a mobile phase, is poured into also called TLC chamber, which is called chromatography chamber, with such amount so its level will not touch the spotting line of the chromatography plate. So as you can see on the picture, this some level of the eluent or solvent, and the starting line should be above such level of the solvent. So it should not, so the substances should not connect it to the layer of the solvent. So it's not dissolved in this solution. So after we uh, located the chromatography plate in the chamber, the solvent level will rise and will travel from the bottom to the top. So it will start from the starting line where it's connect with the samples, and then travel to the top, to the finishing line, where such samples will be separated or left depending uh, on the nature of this such solvent. So the TLC placed inside the chamber. Chamber is closed, usually with watch glass, to prevent the evaporating of the solvent. When the solvent reaches the solvent front line, the TLC plate is removed from said chamber and is left to dry. So in some cases, it is removed when we are not marked the such finishing line or solvent line. It can be drawn later when we remove such plate from the uh, TLC chamber and draw in later, but in given work, which we will see the video today, we already drawn the line, and such plate should be removed when the solvent front reaches the said line. And you could see also this in the video. After drying is completed, the spots for each individual substance should be marked, usually in the middle of the spot. In some cases, some spot or dots could be hard to mark, but usually it's in the middle of such spot. And later we should examine its retention or retardation factor. So in some cases, we will be dealing with invisible substances, but for this work, we will be dealing with some uh, colored substances that can be seen clearly on this plate. But in the cases that substances are not colored, there several methods can be used to visualize the spots. For example, visualization of the chromatography plate using ultraviolet light, as been seen on the left picture. Some compounds also can appear dark against a fluorescent green background, for example, in fluorescent green light. And also In some cases, you could use a chemical stain to visualize a plate. For example, such chemical stain is calcium, potassium permanganate, or iodine. So you could also visualize some invisible spots by this method. But you should also choose its method carefully, because in some cases it could dissolve some substances. The next, we should examine what is retardation factor. It means retardation or retention factor is the factor which is defined by the ratio of the distance traveled by the center of a spot to the distance traveled by the solvent front. So the solvent front distance is the distance from the spotting line to the finishing line, which is marked on our plate, and the distance traveled by a spot or the substance is also marked by the center of such spot. So you should uh, you should go you should make some correlation the distance traveled by the compound to the distance traveled by the solvent. So how this distance measured are shown on the picture. So you could see how this distance are measured. That usually measured by the simple meter with gradation scale. And by this retardation factor, the different substances can be identified. If they're seen in the mixture, you can place the spot, for example, for clean substance, and correlate retardation factors for clean substance and substance in the mixture, and make a assumption if this substance is the same. If it has the same retardation factor, then the substance usually is also the same. And this retardation factor, has been said before, depends on characteristics of mobile and stationary phases, usually more dependent on characteristics, polarity or non-polarity of mobile phase, such as solvent or eluent, as it's called. So the next, let's watch the video about chromatography.
Расчерчивать нужно очень аккуратно, мягким карандашиком. Просто вот так, едва касаясь, чтобы только было видно. Здесь вот есть такие желобки, видно, накатка должна быть параллельно длинной стороне пластины. К одному сначала попытаемся наносить 3 на 3 хотя бы. Он течет. Ну, хлороформ вечно течет, уж ничего не поделаешь. С пробирки ничего назад не сливаем в бутылку. Сколько слилось, столько слилось. Пусть лучше чуть-чуть там будет 3 мл хлороформа плюс 3 мл гексана. Всего должно быть где-то 6. Ну вот так вот оно и есть. Сейчас мы посмотрим, хватит этих 6 для того, чтобы там... Это у нас 1 к 1. Это будет вот сюда. Оп. Перемешали. Но нам хватит 6. Так, а вот здесь 3 к 1. Это всего 4 части. Намешаем. 2 миллилитра гексана и 6 миллилитров хлороформа. 2 миллилитра гексана. Снова. Это довольно сложно. Конечно, лучше бы это пипеткой делать. По-человечески, а не так. Я уже, к сожалению, тут налил 3, поэтому 3 части. Надо еще 9 добавить, да? Значит, это я добавляю 6, 7 и еще потом 2. Вот так вот. Потому что 3 есть. Еще сделаем. Сейчас. Теперь хлороформ. Это из бутылок больших, конечно. Ну, очень удачно все делается. Сейчас. Еще туда надо чуть-чуть добавить хлороформа. Чуть-чуть. Миллилитр. Потому что там уже вот так вот. Еще надо будет его в промывку добавить. Или можем прямо отсюда слить в промывку. Так, это сюда. Вот такая пробирочка специальная. Из этого здесь довольно много. Я и возьму в промывку. В промывку для капилляра. Банки накрываем, все готово. Начинаем расставлять пятна. Это закрываем. Пятна на пластинке. Начинается с азобензола. Нам надо расставить 4 пятна вот примерно по такой схеме. Ну, давай, вот берется для этого дела капилляр, более-менее приличный, с торцом, с ровным. Сломанный торец должен быть ровненьким. Набираем. Оп. Вот он схватил. И так более-менее уверенно. Опа. Ага, не хочет. Вот так. А вот так. Нанесли избыток на фильтр. Вот и закрываем. Промываем. Вот таким макаром. Окунаю быстренько туда, на фильтр. Это чтобы не использовать 20 капилляров. Так, следующее пятно у нас Судан 4. Быстро набрал Судан 4 и уверенным движением, не перегружая. Вот эта вот перегрузочка небольшая, концентрация хорошая. И промываю капилляр. Так, сюда. Дальше идет смесь. Смесь, вот она. Так. Упс. Есть. Моем от смеси. Так, смесь закрываем. И остался Судан 3. Угу. Убираем Судан 3. Оп. Оп. Какой-то немного странноватый, но ладно. Будем считать. Промываем капилляр. Все, капилляр готов для дальнейшей работы, если оно понадобится. Значит, после того, как пятна подсохнут, они наносились из хлороформового раствора и уже должны высохнуть. Пластиночка аккуратно умещается. Аккуратненько помещается в камеру для хроматографии. Довольно уверенно. Вот так вот ставим и все. И накрываем. Раз пластинка и два пластинка. вторую камеру. Опс. Все. И теперь нужно дождаться, когда фронт дойдет до верхней черты. Время подошло. Черта. Извлекаем на сушку. Сейчас вторая подоспеет. Просто высохнуть должна. Можно, в принципе, уже ее трясти. Ничего страшного. Вот вторая подходит. Крышку достаем пластину. Уже не страшно. Пятна разошлись. Сейчас мы чуть-чуть. Вот так вот можно сравнить, пожалуйста. Хлороформ 3 части на 1 гексан работает более сильно, продвигает, хотя разница небольшая, что удивительно. Ну и видно, что смесь, это третья линия, состоит из суданов 3. Вот он у нас схемка как раз тут есть, пожалуйста. Судана 3 и азобензола. А вот в Судане 4 есть примеси. Черное что-то пробежало вперед, потом оранжевое есть и еще пятно, которое отличается от Судана 3. Видишь, как вот так вот. Еще один эксперимент сделаем на чистом хлороформе без разбавления. Снимем третью пластинку, посмотрим, насколько сильно они разойдутся. Просто сюда чуть-чуть приливаем вот так хлороформу. И все, и пластиночку туда сейчас. Так, прямо тут. Давай. Так, и раз. Пятна разбежались вообще хорошо. Так, пришло время равнять. Значит, пятна помечаем по центру каждого пятна, делаем вот такие вот засечечки примерно. Не обязательно там уж слишком точно, но видите, здесь немного разбежались желтые пятнышки. Все, нужно измерить просто расстояние в миллиметрах от старта до, значит, здесь 7, до желтого 40, 41. Здесь до сюда на 3, 15 миллиметров, до азобензола 45. А до сюда на 4, 18.
So the video is ended, and there you also could see the table which is represented on the next slide more clearly. So this the table of retardation factor for this work. So you could see for different type of solvents, for example, chloroform, which is first is pure, the second is chloroform to with hexane in ratio 1 to 1, and the third is chloroform and hexane in ratio 1 to 3, and different distance traveled by the spots. The first is the pure substance of azobenzene, the second, third, and fourth are the different mixtures, different mixture. Some of them are pure, some of them are mixtures. So you should, in this case, your task for this table, you should calculate the retardation factors for all compounds by comparing its values. You should define the components of the mixture. By mixture means the third substance, which is called mixture. And you should choose from which compounds it is made by comparing its retardation factors. And you also should choose which solvent had the better separation, meaning in which solvent you have the better separation or better retardation factors between two substances. In this case, for mixture, where the distance traveled by two different substances are longer, where this distance is longer, the difference between two spots is higher, the better such solvent will be in this case. So you also could find here the scheme for this work. The next slide, the presentation for this work, how this method is made on this by the steps which is shown on the video, and the question about the video which are concerned about some techniques performed in the video. And finally, that's it. So for today works at all. You should also write a report about thin layer chromatography made by the same way as you made the previous three reports. So also add the samples of reports for the previous works, so you could do reports on the sample of the previous reports. So you could find as I showed at the start of the class, example for the second report, example for the first report already here. I also add example for the third report with all the necessary elements such as scheme for the work or table if you need it. This table will show so you not just it will be easier for you to work with it. And the same there would be for the thin layer chromatography. I also add the text document which you will work and add your necessary marks for the report. So for today, I think it's all. If you have any questions about your reports or some.
Yes.
Mhm.
Sorry, do we use the same compound for all the reports?
You mean compounds? Uh, minute.
Chemical compounds.
You mean this name, subject, title,
Yeah.
equation? Yes, yes. You use the same by different substances, of course. There would be in different reports. For example, for second report, there would be such substances. They are not the same. For the first, different table, of course, and different structure of installation. So you could see the structure for the second report and the table I contain the table in here so you can use it for your work. You should add some um, parts such as your name, for example, uh, formulae, structural formulae for the compounds, all of them benzoic acid, phenol, naphthalene, hydroquinone, sialic anhydride, and description of work progress, which is you should describe what you see in the video and put the description in your report. And also you should designate the main parts, for example, for the installation which is used for the work. Some of them already here, the other you should add. And you should answer the questions about the video, which should be also will be in the example of such report. After answering the question, you should answer the task, which is usually will be in all your um, works. And finally, conclusions of the work. So all those that with bold text, all the parts that should be in your report. So description, table, structure, questions, task, and conclusions. So for different works, there would be different conclusions. I also write what you should be done, what conclusion should be for the concrete work. So any other questions? You have any
Yes,
No,
questions?
no,
Yeah.
yes,
no.
yes. Can you hear me?
Mhm. Yes, I hear you.
Yes. Hello. Today I have just awful connection. Can
Mhm.
you please upload this video in in Moodle because I went
Vi
off sometime and
video about what I told you today, or what video? Or video about lab?
yeah, this lecture. I mean,
Oh, this lecture. You know, I try, but the limitation for the video about 100 megabytes. I'll,
oh,
so
mhm.
if it will be possible, I could add it to the YouTube and add the link. So maybe I could also. Uh,
Okay.
maybe it's possible. Yeah, I could add the link to the
Yes.
video. So
Thank you very much. But if it's not possible, I will just revise your presentation and maybe if I will have
yes,
some questions,
all
I
the
will.
information you can find in the presentation. So the and in the video, which is necessary to perform your task. So
Yes, yes. Okay, sorry one more time. Thank you very
mhm,
much.
it's all right. So any more questions? So if you have no more questions, so I think we can finish our work today. So what you should do, you already know. So you should uh, should send some reports. First, sublimation, who is not sent today, and next crystallization report, and finally melting point determination and thin layer chromatography. And there would be the last work, which is called this Diels-Alder reaction, which will be on the next week. So if there are no more questions, so I think we could say goodbye for today. Thank you.
Thank you very much. Have a nice evening. Bye.
Goodbye.